Bases. The solutions of substance like sodium hydroxide, or otherwise we can say caustic soda, lime, otherwise we can say calcium oxide, and washing soda, sodium carbonate, are bitter in taste and soapy to touch. The feel is soapy or a slippery feel. They are called bases. Thus, bases are those chemical substances which have bitter taste, and soapy touch. Bases are chemically opposite to acids. They are chemically opposite to acids. When bases are added to acids, they neutralize or cancel the effect of acids. So we can also define a base is a chemical substance which can neutralize an acid. Which can neutralize the effect of acid. All metal oxides like sodium oxide, metal hydroxide like sodium hydroxide, are bases. For example, sodium oxide, sodium hydroxide, calcium hydroxide, ammonium hydroxide. Ammonium hydroxide is not a metal hydroxide, but it is showing the character of a base. Metal carbonates and metal hydrogen carbonates. Metal hydrogen carbonates like sodium carbonate, calcium carbonate, sodium hydrogen carbonate, otherwise we can say sodium bicarbonate, are known as bases. Now we have to refer a term known as alkalis. What is an alkali? Most of the bases do not dissolve in water. Some dissolve in water without any chemical reaction. Only dissolution, no chemical reaction is taking place there. The base which is soluble in water are called alkali. So alkali is a new term, that is soluble bases in water are known as alkalis. They are useful in many fields. Now we have to refer what do all bases have in common. What do all bases have in common? When a base is dissolved in water, it always produces hydroxyl ions. When it is dissolved in water, it generates hydroxyl ions. Base is a substance which dissolves in water, producing hydroxide ions in aqueous solution. For example, we can refer sodium hydroxide. Take the example of sodium hydroxide. That is a solid substance, and when reacted with water, or it does not react with water, it dissolves with water, it forming sodium Na positive or sodium ion and OH minus ion. Potassium hydroxide is a base and it is dissolving in water, producing K plus and OH minus ions. MgOH2, otherwise we can say magnesium hydroxide ions, that is producing, when dissolving in water, producing Mg2 plus and OH2 minus ions. So we can say the basic character of all these substances are due to the OH, the presence of OH minus ions. OH minus ions. From this example, we can conclude that common property of all bases or alkali is that they all produce hydroxide ions when dissolved in water. Now, come to another point: strong and weak bases. Strong and weak bases. What is a strong base and what is a weak base? Strong bases. A base which completely ionizes in water. A base which completely ionizes in water and thus produces a large amount of hydroxyl ions. Large amount of hydroxide ions like sodium hydroxide and potassium hydroxide are known as strong bases. And what is the weak base? Weak bases are the substance or the bases which are partially ionized in water. That is, they are ionizing partially ionizing in water, producing small amount of hydroxide ions, is called a weak base. Is called a weak base or a weak alkali. Ammonium hydroxide, calcium hydroxide, magnesium hydroxide are the examples of weak bases. Now we have to check what are the properties of alkalis or bases. The important properties of water soluble bases or alkalis are: bases are bitter in taste, which we have referred earlier, and it gives a what? For touch it is like soap, a soapy feel or a slippery feel. Bases turn red litmus into blue, which we have referred in the first phase of this chapter and in the last year also. Red litmus into blue. It can, like acids, it can conduct electricity. When a base is dissolved in water, it split up into ions. Due to the presence of ions, it is conducting electricity freely. Otherwise, we can say they are electrolytes. Bases react with some metals to form hydrogen gases. Bases react with some metals to form hydrogen gas. Take the example of sodium hydroxide, a strong base, reaction with zinc metal. When heated, the aqueous solution of sodium hydroxide, when heated with zinc, it produces sodium zincate. What is that? Sodium zincate and hydrogen gas. Sodium zincate and hydrogen gas. So let us check the balancing of this equation. Na, how many Na here in the reactant side? 1, and how many here? That is 2. So put a 2 here, and how many O here? Now it is 2. Now it is 2, and this is also 2. Hydrogen is 2 here now, because it is common for this also, and H is there in the reactant side, and the 2 H is here in the zinc. How is here? Only 1, and only 1 is here, so it is balanced. Salt formed by the reaction between base and metal. The metal is present as a part of negative ion, not like that in the acid reaction with metal. It is in the negative side only. Na2 will be positive, and this is a zincate, sodium zincate, and zincate ion is negative always. It is very important to note that all the metals do not react with the bases to form salts and hydrogen gas. Bases react. Next one is bases react with acid to form salt and water. That's a neutralization reaction which we have referred earlier. Bases react with acid, react with bases to form salt and water, and bases also react with acids to form salt and water. Now let us consider this example which we have referred earlier. Sodium hydroxide, when react with dilute sulfuric acid, what will be formed? Sodium sulfate and water. This is known as a neutralization reaction, that there will be no acidic and basic property after the completion of this reaction. When acid and bases combine, then the real neutralization reaction occurs due to the combination of hydrogen ions present in the acid combined with OH minus ion in the alkali, that forming water. We will take this condition. H plus in the acid combined with OH minus of the alkali forming water, and hence it is a neutralization reaction. Now, bases react with non-metal oxides to form salt and water. Non-metal oxides like calcium hydroxide, what is that? Bases react with non-metal oxide to form salt and water. Calcium is a non-metal, and the non-metal oxide is a calcium hydroxide. Calcium hydroxide is non-metal hydroxide, and when it react with that, what will be formed? Calcium hydroxide when react with carbon dioxide, what will be formed? Calcium hydroxide is a base, react with carbon dioxide, that is a non-metal oxide. This is a non-metal oxide, calcium hydroxide. Calcium hydroxide is reacting with carbon dioxide, that's a non-metal oxide, forming calcium carbonate, that is a salt, and water is formed. So non-metal oxide like carbon dioxide is reacting with bases to form calcium carbonate and water. This is also one reaction of a base. Calcium hydroxide when react with a non-metal oxide, that is carbon dioxide, forming calcium carbonate and water. Now let us refer the uses of bases. What are the uses of bases? Some important uses of bases are: sodium hydroxide is used in the manufacturing of soap, paper, and rayon, a synthetic fiber rayon. So sodium hydroxide is used. Sodium hydroxide is a strong base, and it is used in the manufacturing of soap, paper, and rayon, a synthetic fiber. Calcium hydroxide, or we can say slacker lime. Slacker lime is used in the manufacture of bleaching powder. It's a purifying agent. So calcium hydroxide or slacker lime is used in the manufacturing of bleaching powder. And what about magnesium hydroxide? Magnesium hydroxide is used as an antacid. Antacid, that you know. Antacid to neutralize excess acid in the stomach and cure indigestion. Curing indigestion. To cure indigestion, we use antacid, and magnesium hydroxide is important to, or it is inevitable to produce antacid. Now sodium carbonate, or we can say washing soda, for softening hard water. It is used for softening hard water. And what about sodium hydrogen carbonate, or you can say sodium bicarbonate, is used as a baking soda. It is known as baking soda in cooking food, for making baking products, baking powders, as an antacid to cure indigestion, and the soda acid fire extinguishers. It is used in fire extinguishers also. sodium hydrogen carbonate, or we can say sodium bicarbonate. These are the uses of a base.